So we're going to start, excuse me, we're going to start where we left off in class. So what you guys are going to do is, let me add a page here so I can show you. We're going to look first at your page 5, where we haven't filled anything in yet. And basically the structure of page 5 is going to be into quadrants. And we're basically going to be putting a parabola and some information about it in each of those quadrants. And some of this stuff might be familiar based on what we talked about today. It's basically the structure of a parabola. Okay. So, again, 4 quadrants. I'm going to look at 2 at a time on the screen so that you understand what they are. So here we are, our top 2. Notice that both of these equations have y equals and the x is squared, so these parabolas are going to be vertical, opening up or down. This first one on the left says when a is greater than 0. That means this is the case where our parabola is going to be concave up. We know that this is our vertex, and it has the coordinates hk. Within the parabola somewhere is our focus. Our axis of symmetry runs through the focus and the vertex. And our directrix then is going to be below the vertex, the same distance away that the focus is. And you can see here that since the axis of symmetry is a vertical line, its equation is going to be x equals some number that corresponds with the vertex. And for the directrix, that line is going to be y equals something. And then we can't forget the distance between the vertex and the focus, or between the vertex and the directrix, is 1 over 4a. So concave down parabola basically going to look the same way. Your directrix this time will be above the vertex. Okay. I know this parabola is concave down because it says a is less than 0. So we have our vertex. We have our directrix. It's still a horizontal line, so its equation will still be y equals. We have our focus point. And we have our axis of symmetry running through our parabola, which is going to be x equals some number. And again, the distance between the vertex and the focus would be 1 over 4a. The reason I'm emphasizing this, like I told you guys today in class, it's hard to memorize all those equations, but if we understand well the structure of the parabola, which by the time we write these 4 down we should, then it's easier for us to come up with the answers to the questions and put the information in the right spot. So in the bottom half of page 5, notice the equations are going to be x equals and y is being squared. These parabolas are horizontal with their axis of symmetry, so they open left or right. And here you see in the first one, a is greater than 0. That means we're going to open to the right. Our vertex, our focus within our parabola, our axis of symmetry running through them. This time our axis of symmetry is a horizontal line, so its equation will be y equals some number. And our directrix on the other side of the vertex is a vertical line, so its equation will be x equals some number. If I can finish writing this, sorry. So it's x equals some amount. And then for the same equation, when a is less than 0, our parabola is just going to open to the left. Again, all of these having the same structure, that we should be able to pick out our vertex, that our focus is then what the parabola kind of wraps around, and our directrix is on the opposite side of the vertex. And in these 2 cases, again, our directrix is a vertical line, so its equation will be x equals, and our axis of symmetry running through our parabola is horizontal. So remember, when we write the equation of that, it will say y equals. All right, so now let's do some examples. So the examples are going to start on page 6. So just so you know the structure of page 6, which should be a graphing page, we're going to do a graphing example number 1 in the top half of the page. And then in the bottom half of the page, we're going to do example number 2. Okay? So we see here an equation. How we can tell this is a parabola is that one variable is squared and the other is not. When I see that it is the y that is squared, this should give you an indication of which form of the equation you want to use. So I'm looking to rewrite my equation in this form. So the first thing I'm going to do is divide both sides of that equation by -2. And then I'm going to add 4 to both sides to get the x completely alone. So my equation is going to say -1/2 y minus 1 squared plus 4. And if you look at the parallels with the other equation, we can see k values, h values, and our a values. The other thing I should notice is that since this is x equals with y squared, I expect this parabola to open either left or right. And then due to the fact that the 1/2 here is negative, I expect it to open to the left. So I expect a setup where my end result looks something like this. And again, I'm putting this on here to make you realize, like, this is what I'm seeing in my head, so I kind of know where everything goes in the parabola and how to figure it all out. Now, numerically, what I can get from the equation, now that I've identified the a, the h, and the k, I can pick my vertex out of the equation using the h, k coordinate. So h is 4, k is 1. Remember that the k should always be paired with the y value or the h always with the x value. So our vertex is at 4, 1. Okay. Then what I'm going to do is I'm going to have to get some other information on my graph. Now, the one thing I'm familiar with already is that means the axis of symmetry is going to go through here like this. And the axis of symmetry has an equation, in this case, of y equals 1. It's a horizontal line crossing through 1. Now, the step that's newer for me with building the parabola would be finding the vertex finding the focus and the directrix. And remember that 1/4a was what would calculate for me the distance between the vertex and the focus and the vertex and the directrix. And I'm not really going to plug in a as a positive or negative because I'm going to use it both ways. One time when I move one direction for the focus and one time when I move another direction for the directrix. So in this case, I'm just going to use the a value as 1/2. 4 times 1/2 is 2. So I get that the 1/4a calculation yields 1/2 as a result. That means my vertex is half a unit away from the focus, and it is also half a unit away from the directrix. So I'm going to go ahead and put those things on my graph carefully. Look closely if you have to, because it's a little hard on this grid to move just half a unit away. So everything's set up on here, and then let me go ahead and label those. The focus point, notice, has the same y coordinate as the vertex, but it's 1/2 a unit to the left. So if the vertex was at 4, this is half a unit before it, so it would be at 3.5 or at 3.5. And for my directrix, it's a vertical line, so its equation is going to be x equals, and it's taking place half a unit after the vertex, so at 4.5. Now I just need to fill in how wide my parabola should be, and I'm going to do that by using the lattice rectum. So remember, the lattice rectum calculation was 1/a. So in this case, 1/1/2, which gives me 2. So this means that there is a segment that if I connected it through the vertex from one point on the parabola to another, its total length should be 2 units. So when I go to my graph, I am going to look where my focus is, and if the total length of the segment needs to be 2 units, and notice that half of the segment's on one side of the focus and half is on the other. So I'm going to go 1 unit above and 1 unit below the focus to create the line that is 2 units in its entirety. And there's my parabola. Okay, we're going to try another one in the bottom half of this page. So again, I look at this equation. I can tell that this equation is a parabola because one of the variables is squared and one isn't. I'm going to go ahead and try to rewrite it in the form that I want. So I'm looking to get it into this form, a vertex form. So I'm going to have to maybe complete the square or do some other things to do that. So the first thing I'm going to do, I'm going to factor the 1/2 out of the terms that involve x. And for right now, I'm just going to keep my constant there. So I have x squared minus 1/2 times what would make 3? That would be 6x. And then I'm going to go ahead and complete the square. So remember, when I'm completing the square, I'm taking this 6 middle term, dividing it by 2, and squaring it, which gives me 9. Now, I've written plus 9, but that 9 is really being multiplied by 1/2. So 1/2 times 9 is the amount I need to put into the equation. I'm going to put it on the same side of the equation. So since it was being added to the equation over here, I'm going to subtract it on the same side. So it's really like I put nothing. So then when I rewrite this, I have 1/2 as my a value, x minus 3 squared, and 19 over 2 minus 9 over 2 would be 10 over 2, which is just 5. Okay. So now, keep in mind what we plan to have here. This is going to be a concave up parabola because the a is positive and it's vertical. So our vertex, focus, and directrix will line up how you see here. Our axis of symmetry running down the middle. Oops, sorry guys. So some important things that we need to look at is we need to, one, we can start by pulling out our vertex. I'll go ahead and mark what that is. So our vertex is going to be at the point 3, 5. Okay. And that means our axis of symmetry is going to be here, and the equation of that would be x equals 3. Then for my focus and my directrix, I'm going to look at those calculations. So 1 over 4a is going to give me the distance I'm looking for. So 1 over 4 times 1/2. 4 times 1/2 is 2. So again, half a unit because this equation has the same coefficient as the last one that we looked at. So half a unit above the vertex is going to be the focus, and half a unit below the vertex is going to be the directrix. So this means my focus is at the point 3, 5 1/2, and my directrix is the line at y equals 4 1/2. Now to draw my parabola at the correct width, I'm going to go ahead and do the lattice rectum calculation. So 1 over 1/2. Like last time, because of the same a value, we get 2, and that means 1 unit in each direction from the focus to make a total of a 2-unit long lattice rectum. Okay? All right, so looking at our next example. All right, so let me set up the pages for you first. So we're done with page 6. Then what we want to do on page 7, we're again going to split the page in half. Okay? Example 3 is going to go in the top half, but it has part A and part B, like those graphs you just saw flash up on the screen. And then example 4 is going to be in the bottom half. It also has part A and part B. So if you want to pause the tape and you can sketch these graphs, if these were given to you as problems, could you write an equation for each graph? So if you look at the graph in part A, you can see it's a parabola. This one that's concave down, we know that the x would be squared. And you can see the vertex of this parabola is at the point 0, 4. Okay? So if I plug that in, x minus 0 squared plus 4. So I basically have y equals a times x squared plus 4. The only thing I'm missing is an a value. And one of the ways I can get this is I can pick a point off of my graph, because I don't know if those points they've marked are really in line with the focus, so I don't know if those are the latus rectum or what. So what I can do is I can just plug in a point. So I see the point 1, 1 on that graph, and I'm going to go ahead and take and plug that point into the equation as x and y values. And so I'm going to get that a is equal to negative 3. So my final answer is going to be that y equals negative 3x squared plus 4. Part B, and again, if you have to pause it to copy it down, go ahead. You see that the equation faces to the right. So you would expect x equals, with the y variable being squared. We can see the vertex for this equation is at 1, 3. So I'm going to go ahead and plug that in. Make sure you don't mess up the h and k part of it. And again, I need to find the a value, so I'm going to take a point that I can see on the graph. So if, for example, I see the point 3, 1, I'm going to plug that in for my x and y coordinates to be able to solve for a. And so here I get that a is equal to 1/2, giving me my final answer of x equals 1/2 y minus 3 squared plus 1. So we did taking an equation and graphing, now taking a graph and writing an equation, and now we're going to focus on writing equations from other pieces of information about the parabola. So in example number 4, in the bottom half of the page, we're going to write an equation of the parabola if we've been given the focus and the directrix. So a little sketch helps in each of these, and I mean, when I say little sketch, I mean like you don't have to be exact at all. So 4, negative 3 is supposed to be my focus, and y equals positive 4 is supposed to be my directrix. So there's the given information. So what this tells me is that the parabola goes between here, okay, with the vertex being directly between the focus and the directrix. And that also tells me which way it faces. So I expect a y equals equation. What I do know about my vertex is that it's lined up with this focus, which means the x-coordinate still has to be 4. So I know for the vertex it's going to be 4, something. It's above the focus, so the y-coordinate is going to be higher than negative 3. And it actually has to be exactly between where the focus is at negative 3 and where the directrix is at positive 4. So I basically have to find out which number is halfway between negative 3 and positive 4. If I add those two together and divide by 2 to find the middle of them, I get 1/2. So I get that my vertex is at 4, 1/2. So I can put that in my equation. And then I need my a value. You can remember that 1 over 4a is supposed to represent the distance from the vertex to the focus. And we actually know that distance right here. Here's my vertex at a height of 1/2. Here's my focus at a height of 3, negative 3. So the distance between them is 3.5 units. So you could write it as 3.5, but it'd be easier to write that as 7/2. And then we could go ahead and cross multiply and solve for what the a value should be. Oops. So I'm going to get 2 equals 28a. So a is equal to 2 over 28, or 1/14. Now, be a little bit careful in this, in the fact that your parabola faces down, and we didn't really pay attention to that. So make sure when you go back to plug in your a value, you make it negative if you know the parabola is supposed to be concave down. So there's my equation for that. So we're going to do the same idea given some other information. So here it says the focus is at 10, negative 4. So think about where 10, negative 4 would be. And then the directrix is at x equals 5. So the directrix is here at 5. Okay, and this point is at 10, negative 4, which represents the focus. So I know that a parabola here is going to be concave to the right, that this vertex needs to be halfway between the focus and directrix. So I have my starting equation. Again, I know the vertex needs to line up with the focus right here. So I know that the y-coordinate of the vertex is going to be negative 4. And the x-coordinate of the vertex has to be halfway between 10 and 5. So if I take 10 and add it with 5 and divide it by 2 to figure out what's in the middle, I get 15 over 2, or if you want to call that 7.5. So that's going to be my x-coordinate. So I'm going to have x equals a times y plus 4 squared plus 7.5. Then I need my a value. So again, I'm going to use that information about the distance between things. So 1 over 4a represents the distance from the vertex to the focus. If the vertex is at, or from the vertex to the directrix, if that's easier to think about. So the directrix is here at 5. The vertex point moves over to 7.5, meaning the difference between them is 2.5 or 5 halves. So I'm going to go ahead and cross multiply to solve this. So I'm going to get a equals 1/10. Again, make sure you analyze if it's supposed to face right or left when you put that in. Since it's right, we would expect the a value to be positive. So we'll just keep it as 1/10. All right, the last thing we're going to do, and it's going to be on page 8. And page 8 only has one example with part A and part B, so you should be fine. We're going to write equations again, given some different pieces of information. So in part A, they give us a vertex and a focus. So again, a quick sketch is really helpful. If you know the vertex is at 0, 1, and you know the focus is at 0, 5, you can see where the parabola should travel. Okay? So you know that this is at 0, 1, and the focus is at 0, 5. So I know the equation is going to be y equals a times x minus h squared plus k. I know my vertex is at 0, 1, so I can plug in those values. And then for my a value, I can see here the distance between the vertex and the focus is 4 units. From 0, 1 to 0, 5 is going to be 4 units. So I know that 1 over 4a should equal 4. And so if I cross multiply to solve that, I'm going to get that a is 1/16. So I'm going to go ahead and plug that into my equation and simplify wherever necessary. So I get my equation for that situation. The last one says a vertex of negative 7, 4. So negative 7, 4. An axis of symmetry at x equals negative 7. So that tells me it either goes up or down. And then later on, the a is less than 0 tells me it goes down. So I know that this is happening. Okay? So I expect y equals a, x minus h squared plus k. And I know my vertex, so I'm going to go ahead and put that in. And then I don't have the a value. Now, I don't know the distance between the vertex and focus or vertex and directrix this time. However, I do know that the lattice rectum is 6. So I'm going to go ahead and take my lattice rectum formula calculation, set it equal to 6, and solve. And I get that a is equal to 1/6. Now remember, this parabola, as we've seen it drawn, is concave down, so I'm going to make that a negative 1/6. X plus 7 squared plus 4. Okay. All right, so this covers it for parabola. So bring tomorrow. You can start your homework. You can bring questions, whatever is necessary.